Welcome. I've divided the teaching for this exercise into two sections. In the first part, I'll be teaching you how to use trigonometry to solve geometric problems with vectors. And then in the next video, I'll show you how to write proofs. All right, so let's look at the first example involving geometric questions. In this question, we've been given a vector minus 4i plus 5j, and we are asked to calculate the position, the angle that it makes with the positive x-axis. So let's picture it on a diagram. We have a vector that is pointing to the left because I see there's a minus sign in front of the 4. So it has to be pointing up and to the left into the second quadrant the origin. So we want to actually figure out the reflex angle between positive x-axis. Notice the word positive x-axis pointing to the right. So we need to figure out that. So when you're working with trigonometric, remember what we learned in chapter 9 and 10, angles in four quadrants. You label your triangle opposite and adjacent, and you are going to use tan. Now make sure you use the negative 4 rather than the positive 4 because things may go wrong. So when you write tan of the angle and you substitute the values there into the tan inverse, you have to take the tan inverse of this ratio to find an angle. Don't forget that. So then you actually end up with a negative angle, which is fine. This negative angle is actually giving us a clue that we have to add 180 to it because we want to give a positive angle. And when you add 180 to that, you get a reflex angle, which is the correct angle. Is pointing to the left, and well, because this vector is pointing in the opposite direction to a positive x-axis. So we just found that this number here is 128 degrees, 128.7 degrees. Now, there is a longer way of calculating the same answer. If you forgot and you didn't use that minus 4 and you just went with the positive 4 in the tan, this, by the way, we added 180 degrees because we know that the tan curve repeats itself every 180 degrees. If you didn't do that the short way, you might have used 5 over 4 and took tan inverse of 5 over 4. Now 51.3 is the opposite of that, and this is obviously an acute angle, and our vector, what you found there is a acute angle here. 51.3 is this angle here, and this is what we want is its complement with 180 degrees. You could say 180 minus 51.3 to find this complement, or you could have gone even longer way and calculated this angle, let's call it alpha, and then add 90 degree to alpha. So either way, you can divide it into other sections and you should get the correct answer there. Okay, so 128.7 is the correct answer. Now here are some further questions from the exercise which we didn't have example for. So the vector A has a magnitude of 10 and it makes an angle of 30 degrees with the J. It means with J axis, all right, or y axis. So find the values for A in column vector notation. So the fact that it has a magnitude of 10 means that the length of the vector is 10 units long, and the angle it makes with J, it means this angle here in y direction is 30 degrees. So you're going to have to use your right angle trigonometric ratios to figure out components of the vector. Components means in what I direction, how far it goes in I direction, and how far it goes in J direction. So component wise, we said this, you should remember that, opposite here, this is the opposite of the angle. So opposite means that uh, opposite divided by hypotenuse is sine. So if I take hypotenuse from the denominator and multiply it by sine of 30 degrees, I should get the length of the opposite. And the same goes in this case. This is our adjacent there, adjacent to 30 degrees. Usually in trigonometry we measure our angle with respect to x-axis here. But in this particular case, we are measuring angle with regard to y-axis. That's why adjacent seems to be in the y direction, which is the opposite of what I would teach. But here, hypotenuse multiplied by cos of 30 is going to tell us what's that going in j direction. So putting those values in on the calculator, just very briefly, I'm going to wipe this off. And these are the values we type in. 10 is our hypotenuse, 10 times sine 30, 10 times cos 30 is going to give us these values there. And if you want to have a go at these questions down here, I've answered part B. So pause the video, have a go at part B, and I'll reveal the answer. So I hope you've had a go at this. So by the way, that final vector was 5 and 5 root 3, like so. So putting the numbers into this equation, this is the calculation. Again, I haven't gone through all the way to figure out the exact answer there, but that's what you would do just to start you off. All right. So in this next example here, example 3, we've got a triangle. We've been told two sides of this triangle here. The triangle is ABC. We know the vector A to B is, and what a vector A to C is. So what we don't know is the vector B to C. So we've been asked to find the size of the angle BAC. Notice if they've written it like so, the hat goes on top of A, that means they want to know what's this angle A, the middle letter is A, that's what the angle is. They pointing to. So we want to know what that angle is, theta. So the with trigonometry, we can what we learned is that we can figure out the magnitude of A to B and magnitude of A to C, but we still, if you have two sides of an angle, but you don't know the angle between them, know at least the third side of the triangle before you can figure out that angle there. If you remember what we learned in chapter 9, we said if you have side of a triangle, you can figure out any of the angles you want. With which rule do we use? We need to use the cosine rule. Cos of A is equals to b squared plus c squared minus little a squared divided by 2bc. All right, and then finally you have to take cos inverse, of course, to figure out what the angle is. But cos inverse of what I've just written, that fraction there, I would put it here. So we do what I'm trying to say is that what we're missing, we can use Pythagoras here to figure out the magnitude of these two vectors, but we still need to figure out what this vector B to C is, and go ahead and use Pythagoras and figure out the magnitude of B to C after we found what the vector is. So now A to B is that vector there. So these vectors have directions. A to C is what's there. So to figure out vector B to C, we need to go back from A to B. So I'm gonna write A to C first, and then say minus A to B, because we're gonna have to go back in this direction that we came down from A. Notice the arrows here are telling us it has its direction. So what that means is that I'm just gonna use vector notation or column notation here. Right, values of 1 and minus 5 there. That's definition of A to C. And I'm going to subtract definition of A to B, 3 and minus 2. That's telling me 1 minus 3 is a minus 2, and minus 5 plus 2 makes minus 3. So this is the definition of B to C, and well, it happens that we've drawn it is pointing to the left and down. So now we want to know what actually is the magnitude of B to C. So we're going to use our Pythagoras here. Square of minus 2 plus the square of minus 2 square plus minus 3 square. Alright, so 4 plus 9 makes 13. So that's the magnitude of BC is root 13 here. Now we also need to use Pythagoras to figure out what the magnitude there is. So square root of 3 square plus square minus 2 square is the same as 2 square. So 9 plus 4 makes 13 again. Alright, that happens to be the same, and have the same length, these two sides of the triangle, although the drawing doesn't show it. So this magnitude is, I might as well write what I'm working out. It's best to always indicate what you actually are figuring out. Here we figured out the magnitude of A to B is this. So here with magnitude of A to C is 6. So now that we know these three lengths here, okay, we're going to use that cosine rule here. Okay, so squaring, this is little a. All right, so our little a is root 13 because that's opposite of angle A. Our little c is root 13, and our well, that's opposite of angle capital B, so this must be little b. So substituting that into this equation, we'll be taking cos inverse of b square. What b square means 26 because square root will cancel away, plus c square is root 13 here. So c square, c is root 13, so c square is 13 itself, and minus a square, which is 13. And we're going to divide by 2 lots of root 26 times root 13. Don't forget the root here because here we have b and c, not b square and c square. So these two 13s cancel away. You put that on your calculator, and I'm just going to tell you what the answer is. Yeah, you're going to get A is 45 degrees. Okay, so yet I had all these written by hand already, but I wrote it for you again. So there you go. Now this is the angle that we were looking for, 45 degrees. All right, so let's see. This is just going through the calculations one more time. All the values that we found by hand, we found these values, and we are replacing into the cosine formula, and there you go, 45 degrees. All right, so there is one more example here, and this last example before I teach you proof. So in the diagram, the points A, B have position vectors A and B, so we can just put arrows there and label what directions the question just said A and B are pointing to. And it says that point P is such that it divides AB in a ratio of 1 to 2. So this is, if you add the ratios here, add up to 3. So this is like 1/3 of A to B, and this is 2/3 of A to B. All right, just from P to B. Okay. So find all the information, fill all the information on the diagram, and this is just giving us a hint. The question is asking us to find the position vector of P. Okay, so with using A and B, we want to figure out position vector P. So we know going from A to B means going in an opposite direction of A, so and positive direction of B. So we write B minus A, and those ratios. All right, so O to P involves us going from O to A and going one third of a way from A to B. So we can replace, it is important you write the path for yourself. This is, notice the path here starts with O and ends with P. This is just expanding and writing exactly what points we're using in our work. So A to P is one third of B minus A. We're going to replace that there into the definition, and OA is A. So all we have to do is multiply out the bracket, bring this minus a third with A, factorize the A out of that. If you're not sure, what we're doing here is rewriting this as 1A, and we're taking away a third from that, and we end up with 2/3 of A plus 1/3 of B. Okay, so final answer should be 2/3 of A plus 1/3 of B. That's how we add and subtract vectors when you have, you know, fractions and as such. All right, so that's just showing you the same working out again. So that's position vector P. All right, I'll see you in the next video, and I'll explain proofs in more detail. Don't want to make this video too long.